this is Mike and welcome to BitFixer. Today I wanted to tell you about some new features for the ROMulator, which, if you're not familiar, is a RAM and ROM replacement device with debug capabilities for 6502 based machines like the VIC-20 and the Commodore PET, among others. You can replace your RAM and ROM, you can create new configurations for different 6502 machines, and you can also halt a running CPU and read or modify the contents of memory. The first thing is a change to the way that you can interact with the ROMulator. Up to this point, if you wanted to reprogram the device or do any debugging, you needed to connect it to a Raspberry Pi. If you've looked into buying a Raspberry Pi recently, you might have noticed that they seem pretty much impossible to buy at the moment. I looked on a few online stores and out of stock, almost everything, except for some of the bundles that are more expensive, but all the basic models are pretty much out of stock. So this could become a blocker for somebody who didn't already have a Raspberry Pi but wanted to use the ROMulator. So I wanted to come up with a way that you could interface with the ROMulator without using it. Now really all you need to communicate with the ROMulator and to do the programming and debugging is you need a device that has an SPI interface, and Raspberry Pi happens to have one, which is why it's convenient to use that. But most microcontrollers do as well. And this little board here is something called the Wemos D1 Mini. This is one of many breakout / debug boards or development boards for the ESP8266 Wi-Fi enabled microcontroller. I believe this is an ESP12 module on here. But basically it has a USB port and it has a USB to serial chip on here, so you can program this directly from your regular computer. It's a microcontroller. You know, you can do microcontroller things with it. So what I did is I made some firmware for this, which enables this to be both a programmer and a debug console for the ROMulator instead of the Raspberry Pi. And I have a little adapter board here. So you just plug this in like that. And then this goes onto the ROMulator like so. So you have this thing hanging off here, but now I can program this or debug it directly from a computer using USB, or there's another way to do it that I will show you in a second. So first we'll talk about how to program it. So connect it up like so. And then you power it up with USB. The first time it powers up, since it does not have your Wi-Fi credentials yet, it will create a self-hosted access point called ROMulator, which you connect to. And from there, there's a web portal where you can enter your Wi-Fi information. At this point, you reset the device, and once it restarts, it hosts a web page where you can interface with the ROMulator, including programming and debugging functions. You can upload firmware images from your computer, and then you can program your device, except this time there is no Raspberry Pi involved. You can also reset the device straight from this interface. If your tastes run more old school, then you can use a serial terminal like Minicom, and you can upload firmware images using X modem, at which point then they get programmed into the ROMulator. And you don't have to use the Wi-Fi interface at all. And now we'll try doing some simple debugging with the new interface. I'm going to put the ROMulator along with the microcontroller board into the Commodore PET 8032 here. And in this mode, I don't need to connect a separate USB power source. The microcontroller board is going to get its power from the 5 volts coming from the PET. And we'll type something out on the screen just so there's something in memory. Go back to the web interface and click Halt CPU, and then read memory and you can see we've downloaded a 64K file, which is the full contents of the ROMulator's memory map. We can take a look at that dump in a hex editor, and we've got the full contents of the running pet's memory. If we look at address 8000 hex, this is the screen memory. It doesn't show up in ASCII here because these are character ROM indices, but you can see there's something there. And finally, we can see that we've got access to a virtual screen where the microcontroller board is continuously reading video RAM contents from the PET and sending it to a browser. And there's a JavaScript renderer which is rendering it into a screen image. So while we're set up for debugging here, there's one other thing I wanted to show you. If you've seen one of Adrian Black's recent videos where he used the ROMulator to do some debugging on a PET 4016, he pointed out that if you change the dip switches while the ROMulator is running, it doesn't really do anything. And up to this point, you actually needed a power cycle for the ROMulator to reread the dip switches and to load in a new setting if you wanted to change something. So you can only have basically one setting per run of the machine. So I went ahead and I made a firmware update where that is now it is now possible to change settings while a machine is running. Basically, you don't use the dip switches, you use the debugger, and you halt the machine, and it will update the settings. It will load, if you have new ROMs, it will load the new ROMs in there. It will actually preserve the RAM so you don't disrupt the running machine, and it will load in any changes you've made to the memory map. So if I had a section of memory that was configured as ROM in one setting and RAM in another setting, once you unhalt the CPU and let it run again, that memory will now be RAM. So I'm going to demonstrate that. I'm on setting number 2 here for the Commodore PET 8032, and let me show you the configuration I made to demonstrate that you can actually change the setting while you're running here. So I'm looking at the enable table file for the ROMulator, and setting 2 is what I normally use for the Commodore PET 8032, but the important part here is that we have section 9000 hex to AFFF mapped as pass-through. Now that's optional. Those are optional ROMs on that model, so they don't have to be there. There's no basic or anything there. Those are option ROMs. So that's mapped as pass-through. So if you had those ROMs on the board, you would be reading from there. Now in setting 3, everything is exactly the same except for that section of memory, 9000 to AFFF. I have it marked now as read-write. So basically I'm turning the ROM into RAM for whatever reason, just to demonstrate. But so that means that if we're on setting 2 and we try to write to that section and read back from it, nothing's going to happen. It's just writing to an empty socket. There's no ROM in that socket even. But if we're in setting 3, then we should be able to treat it like actual RAM. And if we look at the memory set, this is what defines the ROMs on different settings. Setting 2, we have the normal ROMs for Commodore PET 8032. And on 3, I cloned all the settings except for the B000 ROM. I made a modification. So basically the word ready, instead of the word ready, it's going to say happy. So we can see that once we switch settings, then we should see that reflected in the change. Okay, well I actually forgot that I didn't implement this feature on the Wemos D1 Mini board yet, so we're back to the Raspberry Pi connected to the ROMulator. And we're on setting 2 there on the dip switches. So let's go ahead and fire up the PET. And this one we expect to be the normal startup. Yep, we have ready here. And now we have 9000 hex to AFFF hex mapped to pass-through, which means that there's no memory in that section of the memory map. So if let's just see what it returns if I do print peak. And then 9000 hex is 36864 decimal. We get 18, which is just a random bus value. If I poke a value there, 36864. Let's do 128. And We'll go back and print the value again, still 18. Okay, so now we're going to go, now it's an opportunity to show you another thing here, which is that there's a, I'm SSH'd into the Raspberry Pi, and the console now has a interactive mode, so I can interactively halt CPU and do all sorts of debugging stuff here. So halt the CPU, and go back and look at the PET. We have no cursor right now, and the light is on in the ROMulator, so it is indeed in halt. And C for change configuration setting. I'm going to change for configuration number 3. So now it's doing some stuff, which is basically reading the full memory map, changing the ROMs, but preserving the RAM section, so that's unchanged. And then it changes 1 byte, which indicates the configuration, so that will change the mapping of various regions of memory. So now the 9000 to AFFF region will be read-write, so that's now RAM. So we have, so now if we poke a value there, we should be able to read the same value back. So you can see we're actually still, we haven't started the CPU yet, so let's go ahead and do that. Run CPU. All right, so it's running again. We're blinking. So now, if I print peak 36864, okay, well there's a, okay, well you can see one thing. So there was an 8 there in the way, but you can see that value is 0. And now instead of ready, we have happy, which is what we expected in the new configuration. So I'm going to poke 128 to that same region, that same address again, and we're happy. And now if I print peak 36864, we get 128. Okay, well, it worked. So what we see here, it's not a particularly dramatic effect, but when you're using it for debugging, you may want to be able to change the setting on the fly so you don't have to power cycle the computer. And what this means is that we've changed the contents of ROM here, so that it both updates the ROM sections and it changes your memory configuration, so you can remap different parts of RAM to whatever you want. And specifically in that video that Adrian Black did, you could use this to completely replicate what that clip ROM did, the diagnostic clip ROM. So you can start that up, have it run in high ROM, and then when it says please remove clip, you can change that out, change out all the ROMs, and then it will just continue to run. So I don't actually have there's a loopback interface on the user port, which I don't have right now, but I've been meaning to wire that up, and we'll give that a try. Well, that's about it for now. You have the Wemos D1 Mini board, an alternate way to program and debug on the ROMulator, and you have the ability to change settings on the fly with the new firmware update. I'm going to have some of these available that you can, if you want to get them along with the ROMulator. I'll have a few of them in stock. You don't have to buy this from me. You can just, the Wemos D1 Mini, you can get it, basically any online store. They're very cheap, and they seem to actually be in stock, which is a big advantage. I do have this interface board, which it just connects to the ROMulator's programming header there. You don't really even need that as well. You can just wire it up if you want, but this is more convenient. And I'll offer these, together or just the interface board as an add-on to ROMulator. And that's about it. So thank you very much, and thanks for watching.